Rational Rows, developed by Rational Software and subsequently acquired by IBM, emerged as a forerunner in providing robust software solutions for object-oriented modeling. Tailored specifically to cater to the intricate demands of OOAD, Rational Rows aids developers by offering a visual modeling environment, thereby demystifying complex software paradigms and promoting a more intuitive understanding of the system architecture. Staring at the interface of Rational Rows for the first time invites an awe-inspiring mix of intimidation and intrigue. The toolbars, models, diagrams, and endless options suggest a depth of functionality. Behind every icon and menu item lies a layer of technology dedicated to simplifying the creation and understanding of software systems. Rational Rows is renowned for its comprehensive support in developing robust software models, which form the foundation for creating scalable and maintainable software systems. The subsequent sections will explore its compelling features and real-world implications, underlining why it remains a favored choice among professionals. Unified Modeling Language, or UML, is the lingua franca of system architectural blueprints in the software development world, and Rational Rows speaks this language fluently. With a wide range of diagramming tools, it allows developers to depict complex software designs through use case diagrams, sequence diagrams, class diagrams, and more. This diagram, for instance, illustrates how Rational Rows can create a detailed and precise representation of a system's architecture, providing a clear understanding of the relationships and dependencies among various components. Through its robust diagramming capabilities, Rational Rows not only aids in visualizing the structure and behavior of systems, but also promotes a thorough understanding and communication among team members, paving the way for effective collaboration and decision-making in project development. Moving from models to executable code, Rational Rows' code generation capabilities stand out by transforming meticulously crafted UML diagrams into fully functional code across various programming languages, including Java, C++, and Visual Basic. Here we see a snapshot of how seamlessly Rational Rows translates a class diagram into skeletal Java code, providing a significant head start in the coding phase. This feature not only accelerates the development process but also ensures that the implementation remains true to the designed architecture, thus reducing discrepancies and potential reworks. By automating the transition from design to implementation, Rational Rows effectively reduces human error, augments developer productivity, and bridges the often daunting gap between theoretical modeling and practical application. Reverse engineering in software development involves dissecting existing code bases to extract design and architectural insights. Rational Rows excels in this area by providing comprehensive tools that analyze and convert code back into UML diagrams, offering a visual representation of the application's structure. Pictured here is the transformation process, where Rational Rows takes pre-existing Java code and represents it as a UML class diagram. This capability is invaluable for legacy systems undergoing maintenance or upgrades, allowing teams to better understand and navigate complex code bases without exhaustive manual documentation. These reverse engineering functionalities not only aid in maintaining and scaling existing applications, but also provide a learning curve for developers to understand legacy systems more clearly. This is particularly useful in industries where understanding and documenting large old systems are necessary but daunting tasks. Continuing beyond basic application structure, Rational Rows aids in modeling components and the deployment environment of software systems, pivotal for understanding and executing the distribution of software components across different hardware environments. This deployment diagram created in Rational Rows visualizes the configuration of runtime processing elements and artifacts. Such diagrams are essential for planning and executing software deployment, especially in complex environments involving multiple servers, different operating systems, and interconnected networks. This functionality enhances the deployment accuracy and operational efficiency, ensuring that software components operate harmoniously in their intended environments. In modern software development, integration and collaboration are key. Rational Rose supports these aspects through various tools that facilitate seamless integration with other software tools and real-time collaboration among team members. Here, team members from different geographical locations are collaborating in real time using Rational Rose. This not only keeps all stakeholders aligned with the ongoing changes, but also enhances collective productivity and decision-making efficiency in the software development lifecycle. Such tools ensure that Rational Rose remains not just a design tool, but a central hub for project interaction, discussion, and progression. These functions are crucial in today's globally distributed software development teams and multi-tool environments. Rational Rose's influence stretches across various industries, from financial services to healthcare, each with its unique demand for robust software solutions. This section highlights real-world case studies, where Rational Rose has been instrumental in delivering successful projects. One notable application is in the healthcare industry, where Rational Rose was used to model and develop a complex patient management system. The tool helped map out the entire system's architecture clearly, ensuring all stakeholders had a comprehensive understanding of the project's scope and scale, which in turn facilitated a smoother implementation and rollout. These real-world applications demonstrate Rational Rose's adaptability and efficacy in managing complex software development projects across varied domains, validating its reputation as a vital tool in modern OOAD. Rational Rose is more than just a software tool, it is a vital ally in the field of object-oriented analysis and design. It empowers developers by providing a visual framework to conceptualize, design, and implement sophisticated software systems. From fostering innovative ideas through UML diagrams to bridging the gap between theoretical models and practical code, and from maintaining legacy systems to facilitating global collaborative efforts, Rational Rose stands as a beacon of efficiency, effectiveness, and adaptability in the modern software development landscape. Given its extensive capabilities and the breadth of its real-world applications, mastering Rational Rose is essential for anyone involved in the software development process. It not only equips professionals with the necessary skills to excel in their craft, but also fundamentally transforms how organizations approach and execute software projects for the better. In the realm of software design and engineering, Rational Rose continues to be indispensable, weaving the very fabric of modern software solutions with precision and prowess.